Have you ever wondered how the contact time affects the adsorption process? Well, let's dive right in. Adsorption is essentially a surface phenomenon where molecules of a substance get adhered to the surface of another substance, known as the adsorbent. Now, this is where contact time comes into play. The longer the contact time, the greater the opportunity for the adsorbent or the substance being adsorbed to interact with the adsorbent. Initially, the adsorption process is pretty quick, thanks to a high concentration of uptake sites on the adsorbent and a high contaminant concentration. But as time ticks on, there are fewer residual sites, and the driving force between the adsorbent and adsorbent decreases. This causes the adsorption process to slow down until it eventually reaches its maximum uptake capacity, and that's the magic of contact time. So as we can see, contact time plays a crucial role in the adsorption process. Now let's delve deeper into how contact time influences the adsorption process. The adsorption process, in essence, is a dance between the adsorbate, or the substance being adsorbed, and the adsorbent, the material doing the adsorbing. When this dance begins, it's a whirlwind. The higher concentration of uptake sites on the adsorbent and the higher contaminant concentration make the process swift and dynamic. But as any dance, it too gradually evolves until it reaches a rhythm, an equilibrium if you will. Now, imagine this equilibrium as the peak of the dance, the climax. As we move towards this peak, the equilibration time increases, and interestingly, the pace of the dance slows down. Why, you ask? The residual sites, or the remaining dance floor, decreases, and the driving force, the rhythm between the adsorbent and adsorbent, also lessens. This means over time, as the available sites for adsorption decrease and the driving force between the adsorbent and adsorbent lessens, the adsorption process slows down. So what have we learned about the effect of contact time on adsorption? Well, we've distilled the complex process of adsorption to its core principles. We've seen that adsorption isn't just a simple matter of a contaminant sticking to an adsorbent. There's a dynamic process at play involving equilibration time, uptake sites, and concentrations. Contact time plays a crucial role in this process. It's a significant factor determining the uptake capacity of contaminants. Initially, the process is fast, due to the high concentration of uptake sites and the high contaminant concentration. But as the equilibration time increases, the process slows down. We see a decrease in the residual sites and the driving force between the adsorbate and adsorbent. Eventually, the process reaches its maximum uptake capacity. This understanding of the role of contact time in adsorption is essential in various scientific and industrial applications. Remember, the next time you think about adsorption, don't forget the role of contact time. For more information, please visit Aminulchem Innovation, subscribe, like, comment, and share. Until next time.